So now joining me is the winner of this year's Innovation in Materials Characterization Award, Annamaria Petrozza, coming from the Italian Institute. Your actual award cites your work in time-resolved carrier dynamics measurements. Tell us about the work.
Yeah, so time-resolved optical and electronic spectroscopy is already, I would say, established approach to material characterization. What we really did was trying to find a way to really characterize the materials in real life condition. So the condition that you would find in working devices. So this helped us a lot to really be able to picture the processes, the electronic processes in this kind of materials.
Yeah, so a lot of study needed to be done there. Now the talk that you're going to be doing is going to specifically focus on defects activity, and give us a preview of that talk.
Yeah, so one of the most curious, characteristic of this system that people immediately recognize was what is called the defect tolerance of this system. So these materials are processed from solution, but they show performances in devices which are not really those that you would expect from material processed in such a way. For this reason, have been called defect tolerant. And this is for us as an important fundamental aspect, so understanding how the material could behave in such a way, and of course also applicative, as a strong impact in the application. And the defect, so the nature of defect really is key, is a key characteristic and property to understand why this material can be called really defect tolerant, and in which extent as well.
And we've been, like I said, we've been talking about the potential of perovskites for a while now. How close are we to it really being common in the market?
Yeah, this is a tricky question, especially for me probably, but what we can get from the people, we can see more and more companies getting interested in the material, so being less critical, and I see also companies who are more focused on established technologies like silicon, who are investing more and putting an eye on them. So in terms of stability and performances, the materials have been more and more encouraging. The results we got are more and more encouraging. So I would say that is on the good path.
It's on a good path. A little bit more years to. Is there any specific obstacles that you need to overcome?
Well, the stability, I think, now is the core of the research, really, to make these materials more and more reliable and devices. So there is a very active research on that, both on the fundamental side, so understanding, for example, how defects are affecting the stability of the materials and the devices, the working process of the devices. Yeah, that is probably the main subject of interest at the moment, to get them out.
Yeah, for sure. Well, we'll see. We'll be watching your work. Thank you, Annamaria. Nice to meet you.
Thank you. Nice to meet you as well.